Thank you so much. So welcome everyone again. As I mentioned, our presentation today is part of a series of conversations about AI that Code the Dream is hosting. We began in person in Durham a couple weeks ago for a Juneteenth celebration of technology and creativity. And at that meeting, or that amazing gathering, we introduced a new mobile application called Synthesize that was built by Code the Dream and included Code the Dream staffer Alton Musau, with support from the Black Googlers Network. And we continued our series with an online fireside chat with Code the Dream's apprentice Natalia, and also Zoe Cardi of Encore, who's a senior engineer there. And then today's session features Dr. Patrick Musau, who is a senior engineer at Google. And I'm going to turn it over to Alton to introduce him more fully. And the way this is going to go is that Dr. Musau will give his presentation, and then I will be monitoring the chat for questions. And so if you have any questions during the time, you can put them in the chat, or there will be a chance after the presentation where we can just have discussion and get those questions answered. So thanks everyone, and go ahead, Alton.
Hey y'all. For those who don't know me, my name is Alton. I'm a lead backend developer at Code the Dream. I primarily work on the Vamos app. Also had the chance to work with the Gemini API on the Synthesize app. So I've had a chance to hear Dr. Patrick Musau's presentation, and it's full of just exceptional information. Dr. Musau is a senior software engineer at Google, working on the machine learning architecture and performance team. He earned his PhD at Vanderbilt University, focusing on autonomous cyber physical systems and translating promising ideas from the lab to the marketplace. Outside of work, he enjoys reading, being outdoors, and making music. And so without further ado, it's my pleasure to welcome Dr. Patrick Musau.
Thank you so much, Alton. Thank you all for having me here. Can everyone hear me? Just to make sure that.
Sound good.
Sweet. I will go ahead and share my screen, and then just let me know if you can see this. It is Google Slides, so it's not going to go full screen, but I filed a bug. Anyways, yeah. So thanks everyone for being here. You guys can call me Patrick. Please don't call me Dr. Musau. It's weird. And then we'll go on. So hope you're doing well. Thanks so much for being here. Thanks to Lori and Alton for organizing this session. Today, I'd really like to just share a few reflections of what's going on in AI, in terms of what's going on in the industry at large, and how things are really progressing in terms of our desire to use AI to augment the abilities of humanity, so that we can really creatively solve problems and reimagine the way that we organize the world. So my name is Patrick Musau. I'm originally from Kenya. I'm also an immigrant. I moved to the United States in 2013 to pursue a degree in economics and political science at Furman University in Greenville, South Carolina. But somehow I ended up majoring in physics and applied mathematics. When I graduated, I decided I wanted to do something different, and I moved down the road to Nashville, where I pursued my master's and PhD in electrical engineering with a research focus on really how we can go about ensuring that the systems that make use of AI function correctly when they're used in systems such as drones, autonomous vehicles, and unmanned underwater vehicles. So there I had the chance to do a lot of interesting work within a couple of different fields. And I really got involved in the university's innovation ecosystem, which really led me to my current role at Google, working on AI infrastructure and performance. So in terms of AI, it really feels like we're at an inflection point in terms of the types of technologies that are possible with AI, with a new breakthrough or an innovative application announced every week. And although a lot of this feels brand new, AI, or artificial intelligence, has really been around since the early 1950s, and it's gone through several booms and busts in the subsequent decades. The term AI has really taken on a lot of different meanings throughout these time periods. But largely, the term has come to capture the science of making machines mimic the cognitive functions that we associate with human minds, such as perceiving, reasoning, and interacting with one's environment. And there's been a vast amount of efforts towards the creation of intelligent programs and machines. But today, we often apply this label to two subsets of machine learning that have produced most of the stunning applications that frequently come to mind. And these subfields, namely machine learning and deep learning, are largely constructed by using algorithms to detect patterns and learn how to make predictions and recommendations that they observe in large sets of data. And mainly what that means is that instead of having to identify all of the rules that make up speech, vision, or natural language and encode them into a representation that they can handle, the algorithms that we think about in AI can be created by constructing these large set of examples that the algorithm then learns how to make predictions from. And this format has really changed our expectations of what is possible with computers. And a couple of examples that come up to mind that AI has tackled and also made significant advances in is image classification, where you generate a label of what exists in the image; speech recognition, where you can produce transcripts of what is spoken or even generate music; translation, where you take one sentence in one language and then convert them to another; and then even more nuanced tasks where you can take an image and produce a description of what is occurring in that image. And while solving each of those problems is interesting in isolation and has already produced products that are available to you today, when you combine each of these things together, you can start to create some truly breathtaking technology. And you can start to see why AI has often been lauded as one of the most disruptive innovations of the last couple decades. And there's no doubt that it's going to play a large role in the decades to come. And the example I'm showing here is a perspective of how an autonomous vehicle from Waymo perceives the world around it in order to navigate dense urban environments such as the one shown here. And if we think about the advances of AI within this industry, this has spurred the investment of over $330 billion invested into over 2,000 mobility companies since 2020 alone. And if we zoom out, it's really hard to find an industry where AI is not delivering impact in one way or another. The applications here include things such as market forecasting, user sentiment, analysis of customer reviews, recommender systems that we know and love and interact with in the applications such as Spotify and Netflix, the facial recognition you interact with on a daily basis on your phone, and even the fraud alerts that you get when you purchase something outside of your normal behavior. And robotics is a huge other field that isn't on the slide, but is also pretty significant. Now, in the last couple of years, and largely why AI has really developed so much excitement in the past year or so, is that we've also been able to reverse a lot of the problems that I mentioned previously. We can now take things in textual input, and have these AI models generate these more complex outputs. For example here, simply providing the textual prompt leopard can now lead to hundreds of images of leopards that are realistic, good-looking, and quite plausible in practice. Or even more explicitly, we can now use descriptions of images to produce the artworks that we desire. And in the last couple of months, with the rapid rise of OpenAI and several other generative AI companies, namely Cohere, Anthropic, Perplexity, Meta's Llama, and Google's Gemini, we've really seen the development of conversational systems where you can interact with an AI system in a manner that is quite human-like and helpful for numerous tasks. So now, if we look at some of the amazing applications that these generative AI makes possible, one of the most exciting things about this form of technology is that it now presents the opportunity to lower the barrier of entry for the development of really cool applications to the problem of simply describing them in text, which can have huge benefits in terms of enhancing creativity, ideation, rapid prototyping of technical applications, or even in finding novel ways to interact with media. Personally, for me, I use generative AI to look up documentation because it's much easier than Google search. So while many of these things are still also being fleshed out, this form of AI is helping programmers eliminate repetitive tasks. It's helping writers ideate as they write articles and papers. And I could go on about several other applications. This is also one of my favorite ones. And if we look at the pace of innovation within this space, it's really simply staggering. The number of startups within this space is huge. And at the same time, we're also seeing established players within the space start to reinvent themselves as AI-first companies. In fact, Google underwent such a transition a couple years ago in becoming an AI-first company. But also, there have been significant advances within other sectors such as education, finance, infrastructure, automotive, healthcare, or even gaming. And there's a real belief here that we can reimagine how we organize our cities, we move around, and learn so much more. And just like I said previously, the belief that we can really reimagine how we do things is central to how we are operating at Google. Our CEO, Sundar Pichai, has regularly said that AI is causing us at Google to rethink everything we're doing in our aim of organizing the world's information to make it universally accessible and useful. So let me take a step back for a moment and talk about what it is you need to be successful with machine learning or AI. The first thing is high quality data sets. Since ML learns by example, it's pretty self-evident that you need good examples. I used to say that you needed large quantities of data, but I think it's important to stress that although ML does work best when you give it a lot of examples, the quality of those examples are equally important. Let's imagine an example of trying to learn what the concept of a dog is as a human. Now imagine you grew up never seeing a dog. You never read a book about a dog, your family never said the word dog, you never even saw one on TV. Now you go outside and suddenly you see a dog for the first time. What do you think are the chances you'd spontaneously say, that's a dog? It's pretty slim. Now, there's actually a much deeper topic around training data and also training your machine learning systems with this data. But for now, I'll leave you at this. You need to train your ML systems with data that is representative of what it'll encounter in the real world. ML systems are the ultimate example of garbage in, garbage out systems. The second thing is you're going to need a lot of compute. Your brain is an amazingly compact, powerful chemical computer. The average human brain weighs about 3 pounds, and it consumes something like 20 watts of power. To replicate that, we need systems that are much bigger and much more powerful just to the efficiency loss in the systems that we construct. In fact, it's realistically much more compute than most companies have available in their data centers. But realistically, the cloud is the only way that most companies can tap into this kind of computing power. And finally, you need good tools and frameworks. Although I know several of you could probably describe to me the basic ML algorithms to me in a few minutes, they're quite tricky to implement. So we all can't afford to try and implement them starting from scratch, especially with all of the state-of-the-art advances that seem to happen every week. But if we're successful in meeting each of those 3 criteria, then we can start to really create intelligent models that can handle the things that we want to do. So now I'd like to speak about a couple challenges within this space. The first being is that as AI and machine learning applications have become more powerful, they've also become increasingly more complex. More specifically, if we look at one of the most popular forms of machine learning that consists of deep neural networks, the size of these models has generally doubled in size every 3 months, under the assumption that larger models will unlock new capabilities. For state-of-the-art models today, the number of parameters that define these models are on the order of billions. I wrote this slide a couple weeks ago, but now it's probably trillions. And we haven't exactly seen diminishing returns on their performance. But at the same time, in order to sufficiently make use of all of these parameters, the data sets needed to train these models has also increased. And the result of these 2 trends is that the compute cost of developing AI applications is now staggering. Depending on who you ask, over the last decade, we've seen the computing demands of these models increase by over 750 times on average every 2 years. Whereas the innovation in our hardware has sustained a growth of over 2x every 2 years, primarily due to technology headwinds. But additionally, it has also led to some really unique innovations within this space. And one of the key ways that we are addressing the increase in computational demands associated with this AI is through the design of specialized hardware units that are often referred to as AI accelerator hardware. The terms that you are likely familiar with are graphics processing units, or GPUs, or tensor processing units that are unique to Google. However, the essential nature of these devices is that they are optimized to perform the calculations that make up the majority of these models, which is essentially large matrix multiplications. But these chips have been custom designed to be able to perform these calculations up to 1,000 times faster than regular CPUs. We can then take each of these individual chips and design supercomputer systems that allow us to scale our compute performance enough to advance the state of the art in machine learning. But realizing these benefits requires that we understand the joint interaction of compute, memory, network, and power requirements of each of our infrastructure. But at the end of the day, what this really means is that it allows us to take tasks that require months to complete and really shorten the time needed to develop them to hours or even minutes. But also take these models that we're leveraging and scale them by 10 to almost 100x to see what kinds of things are possible. And within this arena, we are really just getting started. Google has really been designing custom accelerators for over 10 years now. But the need for these kinds of designs has never been greater, not only to meet Google's needs, but also to meet the needs of our customers who seek to leverage these technologies to really power their businesses. And if we look at just the growth of generative AI in the last 2 years, we saw more than twice the number of generative AI projects in 2023 as in all of 2022. And we know that's just the tip of the iceberg. That's just generative AI projects. So if you're interested in things at the intersection of AI, computer architecture, design, there's certainly significant demand for folks like you. So I'd like to wrap up with a few notes on some of the challenges that the industry is facing as a whole. The first being that the growth in this AI ML infrastructure has really led to a significant increase in the energy costs required for these data centers. The costs can be traced to multiple factors, but if we think of just about 2 of these factors, the first is that the massive computational workloads in AI ML data centers require significant power to operate. And additionally, as they are operating, they generate a substantial amount of heat. So we not only have to provision enough power to run the workloads, but also to power efficient cooling systems that are essential to maintain optimum temperatures. And if we look at the trends in the industry, if we look at Ireland, for instance, data center energy costs are projected to account for 32% of the country's power consumption. And I know all of the large tech companies are significantly increasing the size of their fleets. So there's a great deal of work needed in this arena to address the growth in energy costs. So if you're interested in energy costs, there's also going to be significant demand for you. Secondly, while a lot of progress in the AI space is extremely exciting, it's equally important to remind ourselves that this technology is not infallible. And this is a significant concern, especially within systems that we term as safety critical. In fact, one of the fundamental aspects of AI is that its advantages often come at the cost of fragility. And what I mean by fragility here is that AI components can fail in unexpected ways. And this isn't simply a limitation of faulty training data or faulty models. It's a fundamental piece of the technology itself. So in a famous study by Christian Cisgetti and his colleagues, the authors demonstrated that by carefully applying small modifications to the inputs that you provided in an AI model, you could cause a successfully trained machine learning model to produce an incorrect classification. And this is what I'm showing on the screen. These inputs are known as adversarial examples, and their discovery has caused really concern over the safety, reliability, and the security of AI applications within safety critical systems. But beyond adversarial examples, the number of edge cases that AI must be able to handle is quite large in practice. And despite our best efforts to estimate all the foreseeable scenarios that these systems must be able to deal with, we often do not have any way of knowing that we've identified all the possible threats to or the failure modes of the system. And given the fragility of these systems, one of the things we must be able to figure out is how to develop principled ways of identifying when these systems are tasked with handling situations that they weren't prepared for. And getting this right is extremely important. And while there's been a lot of work in this space in recent years, there's still a mountain to climb with a drumbeat of news stories of AI failures that range from the trivial to the tragic. And building confidence in these systems will really require holistic analyses of their design and their interactions with the world to ensure that the technology we develop will be consistent with society's goals. So I'd like to stop there before I open up for questions, and thank you all for being here again. AI has really fundamentally changed our expectations of what's possible with computers, and it's an extremely exciting time to be working within this space. It will change many industries in ways that are hard to predict, and while there are many challenges to overcome, I think it's a great time to be optimistic in what we can achieve. So with that, I will open up for questions.
That is awesome. Thank you so much, Dr. Patrick Musau. Maybe we can all give him a virtual round of applause. And Alex, maybe you can take us back to a gallery view, or take off spotlight. And if you all don't see it, you can go to the view in the top right. Oh yeah, maybe you can, oh, that's great. Let's see. Yeah, maybe you can stop sharing your screen if the presentation is done, Patrick, and we can all see each other. Yeah, cool.
Sure.
Great. There are a lot of questions coming in. I've tried to sort of categorize them a little bit. So there's a number of questions that have to do with robotics. So I'll just sort of read out the questions, and maybe you can address them. So is there a huge discrepancy between robotics and AI? Also, seeing that you have studied robotics, we have one of our design apprentices, Asaiya, asks, do you know what collaboration is like between designers at Google working in user interface solutions for robotics? And then we have another question about, do you think that AI will respect the 3 laws of robotics? So maybe you can take those questions as you will and share some reflections.
I think, yeah, I'll start with the last question in terms of the 3 laws of robotics. I think currently where we are with AI capabilities is that, in a sense, the only time I'll see AI violating one of the 3 laws is if there's a software bug. Currently, in today's day and age, most AI applications are not sentient. So it cannot really make any decisions that it wasn't pre-programmed to do. Now, there's a lot of edge cases in terms of how the software works. So if a system is presented with an input that it wasn't prepared for, it's kind of like undefined behavior in most software languages. We're not exactly sure what's going to happen, but we can be sure that it's going to do something that we don't expect. In terms of robotics and AI in general, I think AI is one of the fundamental things that limits unlocking the benefits that robotic poses for society. I think several of the things that I showed earlier in the presentation from the autonomous driving space is we fundamentally needed to figure out how to make robots perceive the world, whether that be from a vision perspective, from an audio perspective. There's not exactly a efficient way to sit down and write a program that can handle all of the images that a system will be faced with dealing with. So in general, there's this idea within the AI space that we typically use AI when we really don't have any better ideas. In a sense, if you were to sit down at your machine and try and write down all of the rules that governed speech, text, or audio, it would be a tough lift. So in that sense, yeah, AI is one of the things that will unlock that. In terms of collaboration between the industries, and I can speak for this at Google, Google has a large bet called Intrinsic that was developed within our X programs, which is kind of like our experimental side of the company, that is seeking really to revolutionize the way that robots are programmed. Currently, a lot of this is very manual. If you want to upgrade the software on a particular robot, you need to know a lot of niche details about the platform, the software, the application space, which makes it really difficult to move systems from one industry to another. So Google is working on that front. On the other side, we're trying to figure out if there's ways that we can use AI to develop control algorithms that allow us to do things with robots that we couldn't even imagine. So I think that area of robotics and AI is an increasingly exciting space. So yeah, in terms of robotics and AI, I could speak forever. There's so many applications, whether that could be in the automotive side, it could be in the aerospace side. It could be even in the unmanned underwater vehicle space, where a lot of companies are investing billions of dollars to figure out where to lay pipes on the ocean floor. So there's a huge space of things that we can unlock.
Thank you so much, Patrick. We have a number of questions related to jobs and AI. I'll just read some of those and you can sort of speak to it, I think, in general. Rebecca asks, right now we have the understanding that AI cannot substitute jobs such as software engineering jobs, but do you think AI can develop to the point where it becomes intelligent enough to substitute such jobs? Then somewhat similarly, let's see, John asks, mentions that AI is a threat to job prospects of students and apprentices that CTD trains because it can do so many of the things that programmers can. So how do our students and apprentices address this threat and keep themselves employable? So Lawrence has a similar question about AI replacing human workers in the space of unskilled jobs, separate from programmers. And then Sonali asks, what steps should we take to find a job in AI? So if you could address this sort of different things, how is AI replacing software engineering jobs, and what can students and apprentices do to stay employable? And then maybe some of the other aspects too about some of the less skilled positions as well.
Yeah, I think that's a really good question. I think it's a question that a lot of us have been thinking about over the last couple of months is, am I automating myself out of my own job? In terms of job security and AI, I think it's really hard to predict, but in the sense, I'll give you this. For the last 20 years, we've been telling radiologists that their jobs will be replaced by AI, and it hasn't happened. Simply because there are so many components to medicine that AI models can't take into account. The second thing from the software developer side is often the hardest part of developing software isn't the software itself. It's aligning with your stakeholders to figure out what system needs to be built in the first place. So unless AI can do that first, you guys are very safe. And I will tell you, it's a very hard job. The one thing, even with that said, there are certain aspects of the job that will go away. The more repetitive a task is, it's the easier it is to be replaced by AI. So you could imagine filling out spreadsheets or simply analyzing logs that have the same structure on the same day. But for a lot of these things, we kind of have to assume that they'll remain stagnant, which is just not reflective of the real world. With that said, I also think that AI systems are going to create a lot more work than we anticipate. In terms of just the technology that needs to be developed in order to support the applications that need to be built. So a lot of large businesses think that they can pivot to AI in a day or in a week. We saw the same thing, the same belief when they thought that a cloud migration could happen in a couple of months, but we know that took decades. So I really think that this technology will roll out slower than we anticipate. Now, in terms of things that we can do to proactively improve our skills to make sure that we're best positioned to benefit from this, it's just figuring out the ways that AI can improve your daily workflows. I think AI can write code right now that looks 99.3% right, and that statistic was completely made up. But then you look at it, upon closer inspection, there's usually bugs. So regardless of if an AI model writes the code, there will still be significant review that needs to happen. Personally, for me, I've used it for writing SQL queries because I hate it. Formatting HTML files, CSS, or doing things that I really don't enjoy. And even it gets that wrong. So it'll take some time. On the manual side of work, I don't see really how AI is going to impact those jobs very much. Then again, I'm not an economist, so we will see.
That's great. Thank you so much for those answers and for the really thoughtful questions from everyone. This is really great. The next one I'm going to ask is a question brought by Leonardo, because it's a question that I also would love to hear more about. What are your thoughts on work that has been done or needs to be done to clean up the training data so as not to reinforce social systems which may have inherent bias?
Yeah, that's a very good question. Yeah, this is one of the things where I think it's going to take a lot of collaboration from folks who are well versed in um, the social sciences and the humanities to really partner with developers to figure out. I think the questions that we have to solve within this space are not just technical solutions, but they're problems around how do we wish to operate our societies. Um, and one thing is, even from outside of the AI training data topic, is a lot of this technology is being developed in one corner of the world, but it will impact users who are across the world, which is something that Google is even thinking about at a large scale. So the questions in terms of how we construct this data will not only influence the US, but will influence the world at large. So it's not really a question that should be left to the large tech companies themselves. Now, outside of that, I think outside of curating your data in specific ways so that it doesn't promote the biases that are existing in society, is really figuring out how to measure those things. At a fundamental level, their computers operate on deterministic inputs. So we need to figure out how to create metrics that capture this. Otherwise, it comes down to rule by committee. So I'm not exactly sure how those metrics can be created. The other thing is there's been a lot of work by Timnit Gebru and a lot of her colleagues that demonstrate that a lot of these biases aren't fundamentally limited just to training data. They are also something that plagues the models themselves and might be reflective of the way that we are currently developing AI applications. The applications that we create don't really have an intense understanding of cause and effect, which is one of the things that would help us reduce some of these harms that AI creates. So I think, yeah, it's going to take a lot of work over the next couple of years. But I think one of the things that I've been pretty optimistic about is watching a lot of these tech companies release reports about how what approaches they're doing to mitigate this, as well as them being willing to continuously iterate and improve their models when harm is presented to them. But yeah, this is a larger problem than a technological problem.
Yeah, great points. Thank you for addressing that. I think that some of what you said gets into some other questions that have come up, but more about in the regulation space. So like Miguel asked, one of Miguel's questions was about is AI and how is it breaking current privacy regulations? And then I think John also asks a really great question about what do we, in terms of regulation, and I don't know if regulation is one of the possible answers to John's question, but what do we do about the ways that bad actors can use AI to produce disinformation, engineer market panics, defraud individuals, and affect elections? Is there a way in which AI can help unmask lies? So maybe you can speak to that question as well as some of the regulatory aspects.
Yeah, I think one of the challenges with the regulatory framework is regulation is always by definition behind the technology. So in a lot of cases, we usually create laws after some harm has occurred, which is not exactly the way it should be done, but that's one of the things that happens. We can even see this in the way the regulation in the autonomous vehicle space occurred over the last decade. I think there's a lot of interesting work that has been written that I would encourage you to read about AI regulation within that space. But I think there's two camps here. There's a lot of folks are pro-regulation in the sense that they want to ensure that the technology we create is beneficial for society. In the other camp, there's folks who want to ensure that the space the innovation space is left alone so much so that we can really explore um, innovative applications or new ways of thinking within the the AI space. So we want to figure out how to balance that, how to make sure that we're not creating something that is going to destabilize society, and on the other front, creating the room for us to be able to do fundamental science. I think one of the things that we have to remember is, as scientists, one of the key ways that we learn is when we mess up. But that said, we also need to ensure that the ramifications are not of the global scale. So if we can really figure out that balance, that would be great. On the privacy side, I really think that most privacy laws really only exist if you can enforce them. And a lot of them are being debated right now at the highest courts. So we're going to have to see what precedents are set in the next couple of years. I think there have been a lot of pretty interesting efforts. So GDPR in Europe, that's really influencing the way that a lot of tech companies are operating in this day and age. But I think we're going to have to wait and see what the courts determine.
What about the question about how are there things that we can do or AI can do for how bad actors are using AI, in particular to some of the destabilizing ways that are there things that can be done to reverse any of that?
So I think we're kind of already doing this in the sense that it is already ridiculously expensive to operate AI. So as a bad actor, if you want to use AI to do a lot of bad work, you're going to have to pay a significant cost, which is a barrier of entry. The other thing is, I think a lot of large-scale providers who are developing these technologies have started to monitor the ways that their technology is being influenced. Because if we really think about it, there's probably 10 to 15 companies that have the compute infrastructure to be able to support these kind of things. And they're pretty vigilant in terms of monitoring how their technology is deployed. Outside of that, there's a lot of work in terms of detecting misinformation, improving the current models we have. Even the ones that we produce sometimes make gaffes that could be termed disinformation. So yeah, there's a lot of work in this space. It's evolves super fast, and anything I'm going to say right now is going to be outdated in a couple of weeks.
Great, thank you. There's so many good questions coming up. Yeah, I guess since we're on the topic of regulation, Shai is asking, do you foresee the implementation of a federal regulatory commission in the US, presumably, to set federal law to address this? How do you see that shaking out?
I don't know. To be honest, I would be surprised if we did. But I could also see why one would want to set up such a commission. But in the sense, when a lot of this technology was impacting autonomous vehicles, or AI has actually been impacting our feeds for the last 12 years, and no such commission has been formed. It would be very interesting to me to see them set one up now. I would need to see the reasoning for it. I think AI is already impacting users, people all over the world, and they haven't. So I'd be very surprised. Whether we should, that's a different question. But yeah.
All right, so just try to get in a couple more questions here. Miguel has peppered us with many questions, but I'll just choose one of his about cognition. Can AI achieve cognition or self-awareness?
Nothing that I've seen so far can do this. But if we could, I feel like Sam Altman would be very, very happy about it. This is essentially what he's trying to do at OpenAI, to create AGI, AI that it is cognizant of itself in a sense. I think the current mode of the way AI is being developed with transformers and large language models will probably not get us there, but it might get us seemingly close. in the sense that it will appear that it is cognizant of itself. But at the end of the day, it's just a computer program. You turn off that machine, there it goes.
Alton asked a really interesting question. Do you see AI as another step in the industrial evolution, like the cotton gin, internet, printing press?
Yes and no. I think yes in the coming years. Right now, no. I think I listened to the All In podcast, which is pretty interesting. But one of the things that they remarked on there was I think there's been upwards of almost $1 trillion spent on AI and AI infrastructure and generative AI. But if we look at the revenue generated by generative AI in the last couple of years, it's paltry. I think it's on the order of like 50 billion. So I'm no mathematician, but that's a huge loss. So the first thing we need to do is figure out how to make this profitable, and it's not entirely clear how we're going to do that with chatbots. But if we do figure it out, I think there'll be a massive disruption to the economy at scale.
Sam Cabrera had mentioned earlier about energy costs being one of her biggest gripes with AI. So I wonder if you mentioned that in your presentation. I don't know if you see any way to pivot for there to be less of an environmental impact, even as the use of AI is growing.
Yeah, I think that's the key question that is going to be grappled over the next 5 years. I think all of these tech companies have outlandish infrastructure needs in order to produce the technology that they want to produce. It's on the order of thousands of data centers in the United States alone. These data centers could also be across the globe as well. And I think we really need to be intentional about how we go about developing them. There's a couple key trends that I'll mention here. I think that we're finally starting to see the size of the models that are being developed for these large models start to decrease, which hopefully will decrease the energy costs. We're starting to see each of the large tech companies develop custom compute in order to better meet the demands of these models. So Meta has their own chip. Amazon is now developing a chip. Google has had the TPU for the last couple of years. But yeah, it's hard to find any large scale provider that's not investing in custom compute. And hopefully we can design energy efficient chips that will also significantly bring down these costs. I think one of the things that people are also hesitant to mention is maybe we need to transition from our current setup of the energy grid to more nuclear power, because that's greener and will more efficiently power our data centers. I think there's political ramifications around that question, but it's been demonstrated time and time again that nuclear power is way greener than our current energy setup. So yeah, there's a lot of questions. Some of them will be political, some of them will be technical, as with much of this technology.
Oh, great. I think here's a really great last question for us before we close out. Or maybe two questions I've got here. But for folks who are interested in this field, what are your suggestions as to the best platforms to get a better understanding on how these algorithms work, and for developing experience to break into these positions? What's your advice?
Yeah, I think there's a couple things I'll note here. One is you do not need any advanced degree to do any of this. I think a lot of the folks who are pushing a lot of the cool developments in this space are just graduating from college. Some of them are just graduating from high school, but they simply took the time to play with the models. So there's a lot of free content on the internet that you can leverage. But I think, yeah, starting at first principles and taking a couple courses in AI and where did it start? How does it work? Would be instructive here. But also, in a sense, I'd also be guided by your curiosity. If you have interest in art and you want to see what these AI models can do in that space, go ahead. If you have interest in music, figure out if you can play with a couple of audio generative AI applications. I think you'll go further if you're really interested in the applications you're trying to develop, instead of sitting down and trying to figure out the linear algebra that makes up of these systems. A lot of that is not particularly needed because they're coded up in applications that already exist. So yeah, I'd just say play around with it. The other thing is develop a portfolio of applications, of things that you've built. A lot of these companies have free APIs that you can leverage. So that's probably what I would recommend in terms of getting started.
That is awesome. Thank you so much, Patrick. And just sort of as our final question, I just want to bring it back around full circle because Asaya asked a very important question earlier on. That was that we heard that you are a musician also, or that you play around in the music space. So tell us a little bit about that.
Yeah. So in the pandemic, when I was stuck at home, I bought myself a DJ controller, which was pretty fun. And I've been messing around with that over the last couple of years. I've released a couple of mixes online. I'm not going to tell you where they are, but if you find them, that's your business. But yeah, that's mostly what I've been doing. It's been a lot of fun.
Awesome. We've got at least one other DJ on this call here. I know Alejandro is also makes some music over there on the West Coast.
Sounds great. Yeah, no, you can share your mixes with me. We'll see if I reciprocate.
Awesome. Well, Patrick, thank you so much for joining us. This has just been a real treat. Thank you, Code the Dream community, for all your very thoughtful questions. And I think that this is just a conversation we will continue to have for a long time to come. And we always invite you, Patrick, to join us when and however you can. And yeah, thanks so much.
Yeah, thank you so much for having me. It was great to meet you all.